Okay, we are looking at literally one of the wildest, most unexpected AI pivots of the entire year. We all know Midjourney, right? The massive generative AI powerhouse that's famous for creating those breathtaking, award-winning images from just a simple text prompt. Well, they are making a massive leap from the digital canvas straight into physical healthcare. They are actually attempting to disrupt the medical imaging industry with a brand new division called Midjourney Medical. So in today's explainer, we're going to break this all down. We have to figure out, is an AI art company really equipped to build full-body medical scanners?
Right out of the gate, Midjourney isn't trying to sell hospitals another loud, intimidating machine. Instead, they're pitching this completely sci-fi, spa-like vision. Imagine this. Their announcement literally describes stepping into a shallow pool of golden light. You descend into the water and let a ring of underwater sensors use echolocation, kind of like a pod of dolphins, to map the inside of your body. It sounds incredibly futuristic, deeply relaxing, and it completely throws the traditional clinical environment right out of the window.
But, we really have to ask ourselves, is this proposed ultrasonic CT a genuine medical revolution, or is it just another classic case of Silicon Valley hype? This is an absolutely crucial question, because let's be real, medicine punishes sloppy optimism way harder than digital art tools do. To figure out if this is the future of preventative health or just a beautifully marketed overpromise, we need to carefully separate the buzz of these shiny new consumer-facing scanners from the established, hardcore scientific standards of technologies like the MRI and CT.
Section 1. The ultrasonic CT pitch. Let's break down exactly what they are fundamentally trying to build here.
Get this. The whole concept relies on 500,000 microscopic acoustic sensors. As your body descends into that glowing spa pool we just talked about, this massive array of sensors acts together to simultaneously send and receive high-frequency sound waves from every conceivable angle. It's essentially 360-degree ultrasound echolocation, and it's generating terabytes, literally terabytes, of raw acoustic wave data every single second.
And their big headline-grabbing selling point? 60 seconds. Think about that for a second. Compared to a standard MRI, which, let's face it, can be super expensive, highly claustrophobic, and take upwards of 45 minutes, Midjourney is promising a rapid, comfortable, radiation-free 3D map of your internal anatomy in just 1 minute. And they're planning to open their first flagship spa in San Francisco by the end of 2027.
And listen, this is not just some conceptual fantasy they drummed up. They've actually backed up this vision with a massive joint venture using Butterfly Network's ultrasound-on-chip technology. We're talking a contract worth up to $74 million over 5 years, a clean $15 million up front, and the integration of 40 of Butterfly's proprietary modules into their prototype. Plus, to handle those terabytes of data generated every second, they're dedicating over 2 petaflops of local computing infrastructure. They are putting serious capital and heavy-duty hardware into making this a reality.
Section 2. Physics versus hype. Because before we go booking a scan at this planned San Francisco spa, we desperately need a reality check on the actual laws of biophysics. You see, leading experts in digital medicine and radiology, folks like Dr. Eric Topol and Dr. Francis Deng, point out an absolutely critical physical flaw in this entire premise. Sound waves fundamentally struggle with something called acoustic impedance. What that means is, when a high-frequency ultrasound wave hits adult skull bone, it is completely blocked. No way around it. When it hits air pockets in your lungs or bowel, the waves just scatter. So an ultrasound system physically cannot penetrate the human skull or your air-filled organs to give you a true whole-body image. Dr. Topol even pointed out that pioneering handheld ultrasound technologies deliberately omitted the head for this exact acoustic barrier reason.
So here is the crucial takeaway when we compare creative AI hype to clinical reality. This unproven acoustic tech fundamentally cannot match the tissue contrast and spatial resolution of established diagnostic standards. While 3D ultrasound tomography definitely exists for things like localized breast imaging, pitching it as a full-body replacement for an MRI completely ignores the biophysical limits of sound. Modern MRI and CT scanners are the gold standard because they literally see right through bone and air. They provide a level of clinical utility that this new scanner simply cannot physically achieve.
And that brings us to a really scary word for doctors: incidentalomas. Clinical professionals are warning that this spa-like screening threatens to trigger a massive wave of these. Because Midjourney's scanner lacks the high spatial and contrast resolution of an MRI to definitively characterize what it's looking at, it is inevitably going to flag completely benign, harmless anomalies in perfectly healthy people. And what does that do?
It leads to severe anxiety and expensive, unnecessary, and sometimes even invasive follow-up procedures like biopsies or contrast CTs just to prove that you were actually fine all along.
Section 3. Creative AI versus clinical reality. Moving from the hard physical limits of the hardware over to the software limits, we uncover a massive gap.
When you actually put these general AI engines to the test with medical experts, the results are, well, telling. Models like Midjourney excel at surface aesthetics and skeletal bone, scoring pretty highly there, but they completely fall apart when mapping deep muscular and neurovascular layers. I mean, look at that nerve pathways score, a dismal 1.55. They can draw you a beautiful picture in the style of a Renaissance anatomist, but they lack the actual underlying biological comprehension necessary to maintain any real spatial or functional accuracy.
And this highlights a genuinely fascinating roadblock known as the algorithmic terminology paradox. Ever wonder why the AI doesn't know anatomy? It's because to protect the public from generating graphic violence or gore, developers literally ban the AI from hearing the exact words it needs to learn human biology. Strict safety filters block terms like incision, blood, surgery, or anything related to reproductive anatomy. So the gatekeepers are basically protecting the AI from the precise clinical terminology it would need to generate medically accurate data.
Because they are optimizing for art and style, general AI models will blatantly hallucinate. Studies have literally shown these models adding cute little heart shapes into medical illustrations of cardiologists, or producing completely unannotated depictions of congenital heart disease, or generating what looks like histology textures instead of actual macroscopic structures. It prioritizes a good-looking, aesthetically pleasing image over a biologically correct one, which obviously renders these commercial engines largely useless and, frankly, potentially dangerous for actual clinical education. Section 4. The power of specialized clinical AI. So, if creative AI isn't the answer for medicine, what on earth is? Let's look at the real revolution happening quietly in the background.
Unlike Midjourney, which is trained on broad, uncurated internet data sets, domain-specific models like RadImageScan are built entirely differently. They are trained directly on massive repositories of expert-annotated, high-resolution medical data. RadImageScan specifically used 1.35 million clinically validated scans covering 130 different pathological classes. Now, this is an AI that actually understands the biology it's looking at. And these domain-specific generators are solving massive, real-world problems for healthcare today. Because the generated images are entirely synthetic, they contain zero protected health information. That completely bypasses all those strict HIPAA privacy hurdles. Plus, they can balance out medical training data by generating synthetic scans of super rare diseases like ALS, which prevents AI diagnostic tools from learning biased shortcuts. Ultimately, using these specialized clinical generators can drop dataset acquisition costs for clinical trials by up to 95%. That's huge. That is the practical, proven application of generative AI in medicine.
Section 5. The future of medical innovation. We're reaching a critical crossroads here. Healthcare leaders absolutely must maintain a strict firewall between consumer-facing, commercial image generators and true clinical diagnostic applications. Because given the hard physical limits of ultrasound bouncing off bone and air, the massive risk of incidentalomas, and those algorithmic paradoxes that literally prevent creative AI from learning real anatomy, we are left with a vital question. As we step into this brand new era of tech, is it safe to let Silicon Valley's move fast and break things mantra govern the future of our life-saving healthcare diagnostics? Should our physical health really be entrusted to a company best known for painting our dreams? It's a fascinating space to watch for sure, but for now, the gold standard remains firmly in the clinic, not the spa. Let me know what you think.